In question 13, it asks about the polynomials, so the Riemann theorem and the factor theorems. So first of all, let's look at the questions. So we have this fx, which is a cubic equations. It is divided by this quadratic equations, and the quotient and remainder is 2x minus 3 bx plus c. So for when you divide it by something a quadratic, it's hardly to use the remainder theorems or the factor theorems. So but you can try to think about it in this way. For example, if you use the 35 divided by 6, which is actually equal to 5, and the remainder is actually 5. So if we write it in this one, 35 divided by 6, we got the quotient, which is 5. This is 30, and the remainder is 5. So we can write it as 35 equal to the quotient times the dividend plus the remainder. So now we can just write this fx is equal to divided by this 4x squared plus the dividend and times the quotient plus the remainder. So we can first of all write down the fx, which is equal to 4x squared plus ax plus 5 times the quotient, which is 2x minus 3, plus the remainder, which is bx plus c. Then we can expand the bracket. So now I have this is 4x cubed plus 2ax squared plus 10x, and then this is 4x squared minus 3, so which is negative 12x squared, and then a times negative 3, negative 3x, negative 15. And then now we have this bx plus c, so bx plus c. And I can plus all of the things together, so I have 4x cubed. Sorry, this should be 8. This should be 8. Because 4 times 2 giving you 8. So 8x cubed, and then plus 2a minus 12 x squared plus 7 plus bx plus c minus 15. So now we can compare to the coefficients of the original fx, which is 8x cubed. They should be equal negative 54x squared plus 68x minus 9. So that these three terms should be actually the same because we can using the method of compared coefficients. So now I have 2a minus 12 should be equal to negative 54. Solving this, we can have negative 54 plus 12 divided by 2, giving you negative 21. And we also have this 7 plus b equal to 68, so that b is equal to 61. And for the last one, c minus 15 equal to negative 9, so that c is equal to 6. And the answer is asking just a, so that a is equal to negative 21. So for part B, we have another gx, which is divided by this 4x squared plus ax plus 5. It's actually the same dividend. And the remainder is being changed. The remainder is actually the same as well, bx plus c. But now we don't know what is the quotient. So now we can set. This is the hard part. We need to set, or we need to let the gx is equal to 4x squared plus ax plus 5, because fx is not equal to gx in general. So we can using the dividend times another quotient, just qx, and I plus the remainder, which is bx plus c. So now they actually ask you to prove that it's divided by this 4x squared plus ax plus 5. Then they're asking about fx minus gx, so we can consider about it. So we consider the fx minus the gx, then which is going to be, the fx is going to be this. And using this way, so we can say this is 4x squared plus ax plus 5 times the quotient, which is 2x minus 3 plus bx plus c. And then they ask you to minus the gx, which is minus, I copy down the whole thing here, so 4x squared plus ax plus 5. I don't know the quotient of gx, so just say qx. And I plus this bx plus c. So bear in mind, this is your fx, and then the right part is your gx. So now we can expand the brackets. The negative I can put it in. So I have this is equal to 4x squared plus dot dot plus this 2x minus 3 plus bx plus c minus this 4x squared plus dot dot times qx. And then because this is original positive, the minus put it in becomes minus as well. So I minus the bx minus the c. So bear in mind, this is positive bx, this is negative bx, positive c, negative c, so they can be cancelled out. So the thing that we left just equal to 4x squared plus ax plus 5 times 2x minus 3 minus this 4x squared plus ax plus 5 times the qx. So now we can say this is the common factor. We can take it out, 4x squared plus ax plus 5 times this 2x minus 3 minus qx. So even though we don't know what is the actual qx, but as we can take out the 4x squared plus ax plus 5 as our factor, so that we can say fx minus gx can be divided by this 4x squared plus ax plus 5. And now we can say that someone claims that all the roots are integer. So now we can say B2 because fx minus gx is equal to this, isn't it? So we can consider this fx minus gx equal to 0 just means 4x squared, the a is negative 21, plus 5 equal to 0. Then we can say, using the formula 01, 4, negative 21, and 5. That's going to be x is equal to 5 or 0.25. But this is not the integer. So it's not all of the roots is going to be integers, isn't it? So one of them is not. That means that not all of them is integer. Then we can say, I do not agree. I don't agree. Okay?